Hey everyone, welcome to my channel. In this video, we are going to look at how I created this self-driving car using neural networks. Now, you might have seen this video on YouTube where I showed step by step how this whole project was created and the demo of what it will look like once it's done. So the idea here is that we have three different steps. Now here I have given different numbers, but if you forget about step number one, which is creating the path, we will start with data collection. So that is your first step in which you will collect the data. And let me actually show you. So here I have an overview of the whole system. So the idea is that we have three steps, and the first one is data collection, where we are collecting all of the data, and then using this data we are going to train our system, and once it learns how to drive, we will implement that back to our robot or our car. So based on the prediction of the steering angles, we will drive our system. So what I will do is I will try to create a single video for each one of these. Maybe the training video will be a little bit longer, I'm not sure, but I will try my best. So today we are going to discuss the step number one, which is data collection. So what this includes is basically that we have these different modules. Now each of these modules is basically a file. So we will have a joystick module, data collection module, motor module, and webcam module. And then we will have the main script, which will communicate with all of these modules to generate the images folder, which will have hundreds of images. And for each image, we will have a corresponding steering value. So we will know, for example, if this happens, then we need to turn right. If this happens, we need to turn left. So instead of left and right, we have a range from -1 to 1. So that will be our analog value rather than digital, where we say left and right. Okay, once we have that, we are going to send that to our training file, and in the training file we will have a lot of code that we have also done in one of the previous videos, which was self-driving simulation using NVIDIA's model. So we will use the same model to actually implement it in real time on a real car. So that is a good thing because we have already seen that the simulation works properly. So to see it running in an actual car, that will be something interesting to see. So talking about the first part here, let me go ahead and show you the code. So here we have the file. Okay, so what we have is you can see here on the left hand side we have these different files, and each file is basically a module except for this main data collection. So we have the joystick module, as you can see here, then we have the data collection module, which is here, and then we have the motor module, and then we have the webcam module. Now the motor module and the joystick module I have covered in a previous video, and there will be links to that in the description, or you can check the complete course where you will find everything in the sequence. And then we have the main data collection. So here you can see this is the data collection main file, and once we run this, it will save all the data in an images folder. Now that folder will be inside this. So we have the data collected folder. Inside that, it will generate all the images, and it will generate a log file which will have the steering value of each image. So let's see how that works. So here I have written a little bit of a description for the module itself. This is the data collection module. So first we are going to see how this works, and then we will put all of this together with the main file to run it in Raspberry Pi. So over here what we have is, first we have to import our pandas and CV2 libraries. So you can go to File, Settings, the project interpreter, and you can add here, you can write Python, oh not Python, OpenCV Python, OpenCV-Python, and you can hit install. You can click here and hit install, and then we can do pandas, and again you can click and hit install. So I've done already both of them, so I will not do that again. So once we have that, we also need the dates and time, and we need the OS as well, and I will share why do we need this later on. And here we have some variables, and you can see here we have some global variables as well. So the first step is to actually get the current location, the current directory, so that we can know how many folders do we have. And what we are doing basically is let me just print it out for you so you understand that. So let's print out this directory. So if I run this, and there you go. So it will print out, this is my directory path. So right now it's showing me this. This was the output. And then once we have that, we are going to check for the folder, which is, what is the name of the folder? Okay, there is a mistake here. Here it should be data collected. Data collected, yeah, should be this. Okay, so this should be, if I run that again, it will give me the whole path, including the data collected part. So you can see here we have the data collected. So then once that is done, let me remove that. And once we get the directory, what we will do is we will find the number of folders that are inside that data collected file. So let me delete that. This was created by mistake. So inside that we will have folders. So because we ran it once, we have right now images 0. So this is the folder, and inside that we will have all the images, and for each corresponding image we will have the, what do you call, the steering angle. So right now for all steering angles we have 0.5. So that is the default value I have given. Okay, so what will happen is that once we run it again, it will create a new folder. Now it will be images 1, and then it will have another log file which is log1. So each time it runs, it checks for the number of folders that are already present, and based on the number that is already present, it will create a new folder. So next time it will create images folder 2, and then we are going to save all the images from to this folder. So what will happen is that this is the main part. So we are saving this here, CV2 I am right. We are saving the file name and the image. So the image we can simply get from our webcam or whatever the user is sending us, because all of this is a function. So whatever the user is sending in, we are going to save that image. Now what will happen is that we have to save a file name. Now usually what you can do is you can write, for example, image 1, image 2, image 3. But what happens is when you run it the next time, it will again save image 1, image 2, image 3, and it will overwrite all these images. So what we need is an absolute unique name. So it should not be repetitive. So one way to do this is by creating a timestamp. So a timestamp will be absolutely unique, and using that timestamp we can add that value to our image name. So it will be 100% unique. It cannot replicate. So this is why we have this date and time, and we are importing it. So here we are finding the current date and time, and we are simply storing it in timestamp. And once we are creating the file name, what we will do is we will add that to our file name. That's how simple it is. So we will write image underscore and we will write the timestamp. So if we look at any of the images here, you can see this is the image, and this whole number is basically the timestamp. So once that is done, we will store the file name and the steering angle, which is coming from, again, from the user. The user is sending the steering angle. So we will save both of them in an array, so in a list. So this list will be image list, will have all the images, and steering list will have all the steering. So the image list, basically it doesn't have the actual image, it has the names of the images. Okay, it has the file name, and the staging list has all the angles of those corresponding file names. So if I open this CSV file, you will see that this here is the complete path. Okay, and then over here we have the what do you call the staging value. So that is the main idea. So this will run once we start the simulation, or we start the actual robot when we want to start collecting the data. So this has to be called again and again once we are collecting the data. Now once the data is collected and we want to end the session, we will call the save log. Now what save log does is it transfers all of that data into this CSV file. So here we are just storing it in lists, but over here we are using pandas. That's why we had to import pandas over here. So we are storing all the file names and their staging angles, and we are putting it all together in a CSV file, and we are saving it using pandas. So here we are using to CSV to actually save it. So once that is done, we can simply print log saved, and we can print how many images were saved. So here you can see we are saying that the log is saved, and we have a total images of 10. So this at the end here is basically if we run the module by itself. So right now when we run this, it is not called by another function, or sorry, another script. It is running by itself. So in that case, it will run this first, and based on this, if it requires, it will call these functions. So what is happening here is that we are capturing our video device, which is basically our camera, and then we are looping 10 times. Now this will be kind of an infinite loop. When we are actually connecting the data, we will turn it on and off manually, but for the purpose of testing, we have just put a value of 10. So it will collect 10 images. So if I put 15 here, it will collect 15 images. So each time it gets the image from the webcam, it is going to send it to save data, and it will we also have to send the staging angle. So I have put 0.5 just for the testing purpose, and then we will put a small delay of 1 millisecond, and if you want to display, you can display the image as well. And at the end of the day, we will save the log. So after we are done with the loop, as I mentioned before, this save log file when the session ends. So here when the for loop ends, we are going to save the log. So that is how all of this works. So let's go and try out the data collection. Where is that main? So in the data collection main, we have multiple modules. As I mentioned before, each module has its own task to perform. Now you might ask, why do we need a webcam module? Because webcam is very simple. As you can see here, it's just a few lines of code, maybe 2 or 3 lines of code, and we can get the image. So why do we actually need the webcam module? And if we open it up, it's very simple as well. So the idea is that you might be using the same image in many different modules. So for example, in the traffic sign, we want the image as well. For lane detection, we want the image as well. For detecting objects, we need the image as well. So we are not going to add the image collection part in each of these modules. It should be a separate module that we collect the image once, and then we send this single image to all of these modules, and it will process and send us the information back. So therefore we need a separate webcam module. So here you can see it's a very simple module. I don't think I made any video for this because it's very simple. So what we are doing is we are importing this. Just make sure it is in the same directory. And as you can see here, this is the webcam module. So all we have to do, this is a mistake, let me delete that. So all you have to do is you have to make sure it is in the same directory, and you will write import webcam module as WM. So M stands for the module. Okay, and then what we will do is we will import the data collection module as DCM, data collection module. Then we will import the joystick module. This I have covered in detail in another video, so the link will be in the description. This module makes our life much easier. So does the motor module. So let me show you that. So this is the motor module. So we are importing it as MM. So this basically is a class. The class is called motor, and based on that we can rotate our robot or the car, and we can move it forward, left and right, and this is how you can move it around, as you can see. So you give a value of going forward or backwards from -1 to 1, and then you give a value of turn from -1 to 1, and then you give a value of delay. So if you want to stop, so here this is the speed, then the turn, and then the time. Again, all of this is I have shown this in detail. You can check out the previous video that I have done on this. Okay, then we are going to first initialize our motor values. Again, all of the hardware and the motor connections are done in a previous video, so you can check that out. All of these videos will be linked in a sequence on the course page, so you can go step by step. I have listed them down so that you can go step by step to follow the complete project. Okay, so what we are doing is here we are basically getting the values of our joystick. Once we have the values from the joystick, we can decide, we can have the steering angle, right? So once we have the steering angle, then we need the image. Once we have both of these things, we can send it to save data, right? Because we need the image and we need the steering angle. So here in the data collection module, so we are going to get our image using the webcam module. So webcam module dot get image. This true is basically if you want to show the image or not, and this is the size of the image. So if you want to define, or you can leave it at default, but here we need to define. So once we get the image, then we need to send the image and we need to send the steering angle. And the steering angle is basically, this is basically a dictionary. Joy value is basically a dictionary, and we need the value of the key axis 1. So this is what I have linked it to. So if I move the axis 1, it will move the steering of the car. So this is why we are sending this. Okay, so once we send that, we will keep recording. So we have 3 states of recording. So the first one is 0. So when we start, the recording is 0. When we press the share button on the joystick, it will update the record value to 1, and it will start the recording. Whenever it's 1, it means it's recording all the images and the steering angles. And once we press once more, when we press the share button, it will stop the recording, because the value will update. It will add +1 to the value, and it will become 2. So it will stop the recording, and to stop it, we have to save the log. So as I've mentioned before in the data collection module, once we have to save the log, save log file when the session ends. So we have to call this function. So here we are calling this function. So DCM, which is data collection module dot save log, and then again we will put the record to 0. So the reason I have put this record value here is because I don't want to turn off the whole system to record again and again. So I just want to press the button, it will start recording, then stop, then it will stop recording. Then I can rotate, or I can put it on the other side, the robot on the other side, or on a different track, and I can start the recording again. So I don't have to run the script again and again, because that will be very tiring. And at the end of the day, all of this is being done to save the values, but we also have to move the robot as well, because if we don't move the motor or the robots, then there is no point of collecting the data. So here we are going to send the value to our motor. So we will say that motor.move, and as I mentioned before, we have to send the forward and backward speed, and we have to send the steering angle. So again, both of these values are ranging from -1 to 1, so we can send it here. And both of these are coming from the joystick. So the throttle value is basically the dictionary key of 0, not 0, this is O. And then the steering value is basically what we are getting from the axis 1. So that is the main idea. And because these values are from -1 to 1, what we have to do is we have to multiply it with 255, or not 255. This maximum throttle is 0.25. Okay, so basically it's restricting it to not to go above this value. So most probably this is basically a button. It is not an analog input, so it is a digital input. So either it will be 0 or 1. So if it's 1, it will multiply 1 by maximum throttle, which is 0.25, and that is the value that we are sending over here, 0.25. So that is the percentage of the speed, so 25% speed. And at the end of the day, we add a small delay of 1 millisecond. So this is how all of our data collection works, and we can use this on our Raspberry Pi directly. Now to run this, you will have to install Pygame. Again, this is covered in the joystick video. And you will have to install OpenCV. Again, this is covered in a previous video. And what else do you need? You need pandas as well. So it's very simple to install pandas. You can write a simple command to run that. Maybe I will put it in the description how to install that. And that is pretty much it. So we can take all of this code and put it in our Raspberry Pi, and then we can run it. So let me show you how that works. So here you can see that I've created the path, and let me just zoom this a little bit. Okay, so here you can see that I've created this path, and what I'm doing here right now is, if you see, this is where I'm pressing the option button. So once I press this option button, it will start the recording, and then I can use I think it was this one or this one of these two, to actually move the robot. So let's run this and see. Yeah, so there you go, the robot starts, and now I'm collecting the data. So as you can see, at this point, once I am collecting, let me go a little bit forward. So at this point, I stopped, I rotated the robot, and I started again. So I didn't turn off the script and turned it on, because I can just press the option button, it will stop recording, and then I will start again, and it will start the recording again. So here you can see, and the same thing happens again here. So this makes the whole process very easy. This, I think it took me around 3 to 4 minutes to grab all the frames. So if I remember correctly, I did this 3 times for each side. So 3 times in the forward direction and 3 times in the backwards direction. So that is good. Let's run that. And once we have that, you will see all these files being collected. So here you can see, I think each folder, yeah, it's written here, each folder had 500 something files. So 500 something images. So here you can see that these are the different folders. So as you can see here, let me show you this. Oh, maybe it's in the front as well. Yeah, okay. So as you can see here, I collected lots of data, but I used only 6 folders. So as I've mentioned before, I did 3 times forward and 3 times backwards. So this is a good thing, that every time I add more data, I don't have to delete the previous data, and all of the logs are recorded as well, and I can select when I'm training. I can select which of these folders I need for my actual training. So when I did the actual training, which we will see in the next video, I just selected from 22 to 16. So these were the files, these were the folders that I selected, and that worked very well. So this is how we can get this file, and let me show you. Okay, this is for the next part. So what we have discussed here up till now is what do you call this part here, the first part, the data collection, where we have the joystick, data collection, motor, and webcam. And after that we have the images folder and the log file. So we have done all of this till here. Once we have that, in the next part we are going to start with the training process. We will use the images folder and the log file that we already have to create this model.h file. So once we have that, we can go back and predict and run our motor through the motor module. And at the end of the day, we will add some other things as well, like traffic detection and object detection. And I'm planning to do this with the NVIDIA Jetson Nano as well, and see what the difference is in terms of speed and accuracy. And hopefully we will have some good results on both sides. So this is it for today's video. I hope you have learned something new. If you like the video, give it a thumbs up. If you like to see more of this content, don't forget to subscribe. And there's a Discord channel as well. If you would like to discuss any of your projects, you can post your projects there as well. Or if you are facing any errors or any issues, you can go to the Discord channel and post something there with some reference images, some code, and hopefully you will get your code or your project resolved. So this is it, and I will see you in the next one.